Again, we have one of those messy trig identity problems. They're asking us to prove that the left identity is equal to the right identity, which is equal to 1. So the first step on the left side is to get the common denominator, okay? So we're going to multiply this side, the left one, by cosecant and the right one by secant. So that gives us cosecant x multiplied by secant x minus cos of x over secant x cosecant x minus secant x multiplied by sin of x minus cosecant x over secant x cosecant x. So next part, I'm going to expand everything in the numerator. So that's going to be cosecant x secant x minus cosecant x cos of x minus secant x sin of x plus, because negative negative gives a positive, secant x times by cosecant x over the common denominator of secant x cosecant x. Now what I'm going to do is I'm going to convert all my inverse trig functions into regular trig functions. So cosecant is going to be 1 over sin of x multiplied by, and secant is 1 over cos of x minus 1 over cosecant is 1 over sin of x multiplied by cos of x minus 1 over cos of x multiplied by sin of x plus 1 over cos of x multiplied by 1 over sin of x all over the common denominator of, and common denominator is going to be now secant is 1 over cos of x multiplied by 1 over sin of x. So now as you can see that 1 over sine cos and 1 over sine cos, they're the same. So there's 2 of those. So we'll group those together. So that gives us 2 over sine of x cos of x minus, next one's going to be cos of x over sine of x, which is these two, minus the next one is going to be sin of x over cos of x, which is that one, all over the common denominator of 1 over, and I'll just write sine first, sine of x times by cos of x. And we can't really divide the numerator and denominators yet, because we have to determine the common denominator for the numerators. So the common denominator is going to be sine of x cos of x. So the next step is, well, this side we don't have to worry about any common denominator because it already has a common denominator. So that's going to be 2 over sine of x cos of x. And this one we're going to multiply the numerator and denominator by cos of x, which will give us cos squared of x over sine of x cos of x. And again, all I did was multiply that by cos of x over cos of x. And this one, I'm going to multiply that by sine of x over sine of x to give us minus sine squared of x over sine of x cos of x. And remember, this is all over the common denominator of 1 over sine of x and cos of x. And I'll just tidy this up a little bit. So that's going to give us 2 minus cos squared of x minus sine squared of x over the common denominator of sine of x cos of x. And what I'm going to do is this was in division form. I'm going to convert to multiplication form. So we multiply by the reciprocal of the denominator, which would be sin of x, cos of x over 1. And as you can see right away, the sin of x and cos of x will cancel out to give us 2 minus cos squared of x minus sin squared of x. And as you can see, I don't know if you can see it, this negative sign, I'm going to factor that out. So 2 minus, if we factor that out, that gives us cos of x plus sin squared of x. We know that cos squared plus sin squared gives us identity of 1. So that's going to be 2 minus 1, which is equal to 1. So therefore, we prove that our left identity is equal to the identity on the right, which is 1.